Hello. What we have here is a World War II aircraft navigation receiver, the BC-453B. At the moment it is tuned to 550 kilohertz, as you can see on the dial, and the signal it is receiving is being fed to it through a 50 ohm terminator from my Hewlett-Packard 8640B signal generator here, also tuned to 550 kilohertz. The receiver sensitivity is quite good. The signal level from the Hewlett-Packard is set at the 1 microvolt range, and the meter of the Hewlett-Packard is also calibrated at about 1 microvolt. So we're very close. Sorry, I'm going to focus a little better. Now we're feeding it with a 400 cycle audio tone with 30% modulation. The fact that we're receiving this 1 microvolt signal on AM to this receiver is, to my way of thinking, fairly significant. This kind of sensitivity is actually very good even for a modern receiver. If we turn the signal level down to 3/10 microvolt, you can still hear it. Although of course not as well as before, but at least it's still there. 3/10 microvolt on AM is a darn good sensitivity. If we turn the modulation off and turn the BFO on, we then hear the carrier. That's a 3/10 microvolt carrier, 550 kilohertz, and we can even turn it down to 1/10 microvolt, and we can still hear it. I hope you can hear it. I know I can. It's with headphones it would even be clearer. I'm going to turn this back up to 1 microvolt because I have other things I want to show you. First of all, I want to exhibit the selectivity of this receiver. This is at 1 microvolt input. If I tune lower in frequency, the other side is 0 beat. There, just barely there at a certain spot, but above and below that frequency is simply gone. So the selectivity of this receiver is quite good. The speaker I'm using is a Radio Shack CB speaker, in which I have connected a 500 ohm to 8 ohm transformer, so that because the output impedance of the receiver itself is on the order of 600 ohms, this matches it quite a bit closer. The power supply on the left is one I built using Radio Shack parts mostly. The two transformers nearest us are 120 volt input, 12.6 volt center tapped output. They're connected back to back. The output of the right hand transformer then is 120 volts AC, and it goes to a voltage doubler power supply that has a pi filter. It's got it's a capacitor input filter. It's got a choke, about 12 Henry choke, and then it's got another capacitor on the output. This power supply is connected to the receiver through a cable that I made personally, specifically for it, and connects to the back of the receiver in an old dynamotor base. This enables you to connect power supplies to your receiver without doing any extensive modification to either the dynamotor connector or the power control connector, which is on the back panel, the back lower panel. That makes it considerably easier to use. Now I'm going to show you what's underneath the lid here. Removing the lid, and we'll find you can see the 6 tubes. It's very compactly built. 6 tubes inside, and the 3 intermediate frequency transformers here. Under the removable lid here, that on each IF transformer, there is a little rod here on this particular model, and also the one that's next higher in frequency. Covers the next higher frequency band, and by pulling up on that rod you separate the 2 coils in the IF cans and can greatly increase the selectivity of the receiver, or if you want higher fidelity you push all 3 rods down. In this particular receiver all 3 rods are now up. Secondly, I want to show you the what I've done to the bottom of the receiver in order to make this, put this back in operating condition. When I first got this receiver, this panel here had not been finished. It has the usual modifications, a BFO switch, volume control or RF gain control, and a phone jack. And that had not been finished. It had several parts missing. Among them, the audio transformer was gone. A lot of the wiring was gone. This particular receiver has been converted from 24 volts for the filaments to 12 volts. Because at the time 24 volt transformers were very hard to get. Now, since that was at least 50 years ago, as you can see, all the CAN capacitors, which look like this, have been removed because these are now shorted and useless. The reason they go useless is because the cans themselves are brass. When they made the capacitors, they filled the capacitors with beeswax. Beeswax is slightly corrosive, very minorly corrosive, but it does react with the brass over 70 years, forming a green verdigris-like substance that renders the capacitors ruined. Totally ruins the capacitors, and they have to be changed or removed. I've removed all of those and replaced them with these 0.047 microfarad 400 volt DC metallized film capacitors, and this receiver is now working at least as well as it did when it was made. This is the audio transformer, which I've replaced. This is the BFO transformer. This is the coil box. Now inside this box there are 3 coils. There's a coil for the RF amplifier down here, there's a mixer coil in the center, and there's the high frequency oscillator coil in this section. This coil box can be easily be removed by removing a screw here and a screw on the other side, and then it simply pulls out. I consider the ARC-V receivers, that's a generic term, by the way, or the BC-453 receiver, the command receivers, to be the very finest single band receivers that have ever been built. Now, I'm going to turn this off for now. I'm going to try to return later with an example of this receiver being tuned to various radio stations in this band. This band, by the way, the 190 to 550 kilohertz band, now includes both the new 630 meter ham band around 500 kilohertz, the long wave broadcast band from Europe, which people on the East Coast can usually pick up fairly easily, and then the NDBs, that is the non-directional aircraft beacons, many of which are still up, and they're an awful lot of fun to look for and to DX. And also there's a band that's devoted to high accuracy GPS stations, which are actually on Earth. They're not satellites. You'll be able to hear those, and I'm going to try to present you with a collection of what I've tuned to with those probably tomorrow night. The furthest NDB I've received with this particular receiver is up in far northwestern Canada. Cannot remember the call letters of it right now, but it was at least 2,000 miles from here. Again, the receiver is unusually sensitive, very selective, very stable, and fully capable as a modern receiver, and in my estimation is compact, it's lightweight, and they're very rugged. Alright, see you later. Bye.